So what we build are robotic gripping systems. So that means both the hand itself, which has soft actuators and assembly that holds them, and all of the systems that go around it. How do you supply air to that system? How do you control that air? Software, AI, you name it. And what that gets rolled into is an incredibly capable system that offers dexterous gripping of objects of variable size, weight, shape, that you can then deploy on a conventional robotic arm in an industrial environment, where our typical customer is someone who has a bit more of a chaotic manufacturing packaging environment than the sort of rigorously controlled environments you'd find in auto manufacturing. So, robots work incredibly well in, let's say, in an automotive plant where a car rolls by and a welding robot puts down a weld, and it's going to do the same job all day, every day, all year in the exact same way because you heavily structured the environment. But the broader world of human endeavor is incredibly chaotic. And as a result, you haven't seen robots truly penetrate the vast majority of kind of manufacturing and packaging and order fulfillment, all these different jobs because of that chaos. And so what we're trying to do is build these remarkably capable robotic hands, leveraging the fundamental soft actuator technology, such that you can actually start doing this kind of work with conventional robotic systems. A conventional gripper that gets highly adaptive grasping, the way in which you accomplish that is, so kind of imagine a Terminator style hand where you have all of these hard linkages and motors and cables, and you can get an incredible amount of dexterity out of that construct, but it comes at the cost of a high degree of complexity. Normally, in order to be able to get a good grip on an object without damaging it, you need to skin it with sensors and have all of that feedback. You might use artificial intelligence systems to identify grasp points on an object so that you can appropriately apply normal force to it and pick it up in a way that you can then translate it. We don't need to do any of that in soft robotic systems. So our systems are inflatable air bladders of, very, very specifically designed to the task, but fundamentally inflatable air bladders that move inward until they strike the surface of an object. And because of all of the passive dynamics in our actuator structures, they know fundamentally when to stop gripping and apply good force to an object and move, and that can all be done in a very open loop manner. We don't necessarily need a force feedback sensor on the tip of a finger in order to know it made contact or to know that it's applying too much or too little pressure. All of that intelligence that would normally be done by software and sensors in a conventional robotic system are now being done innately in the materials themselves. So that's a fundamental difference. What that then means for the user is that it's very easy to deploy our technology. So if all I need to do is strap a robot hand on a robot and command a particular pressure to go in and grip, and it grabs the object the first time, you can program up a new application in an afternoon. And many of our customers can with our technology. They'll have a problem they haven't been able to solve for a very, very long time using conventional mechanical systems. I can think of one that was struggling with a problem for 2.5 years because of the hand. And we showed up at an afternoon and did their project. And that had to do fundamentally with how our actuators interact with objects innately through the mechanics of the design. Now, you can add sensors to soft robots and very, very cool things happen. But what I would say is now you focus your development effort not on trying to nail down the grasping portion of your application. You can apply the sensors and the AI portion of your project towards all the other things that you need to control. And so it frees you up to focus on the big picture as opposed to just trying to get your hands around a target.